Good morning, ladies and gentlemen. It has been a great honor for me to come here to make this presentation. As you see, the title I want to talk is the complexity arising from a larger scale landslide. Maybe it's confused for you, but I want to talk in two sides. One is because most of people when he conduct the large scale landslide project, they maybe think it's a new issue, and we have a different idea of, or we don't know very clearly about this issue. The other one is because in Taiwan, maybe large scale landslide, this issue initiated by CGS, and we found something or some faults that we maybe to conquer or for us is a challenge. Okay. I didn't list any outlines and conclusion in my talk, but I want to talk some topics in it. First, I want to introduce something very briefly about the geology or geomorphology in Taiwan. As you know from this diagram, you know that Taiwan is located at the collation zone between Eurasian plate and the Philippine Sea plate. And so we have many earthquakes. On the right side diagram, you can know that we have at least 33 active faults located in Taiwan. But in the central part of Taiwan, you can't see any active faults. Is it really like that? No, because we don't have enough evidence for that. But then we see this on the left side, this diagram. This is the data from GPS, and the durations from 2002 to 2011. From these years, we have this kind of result. As you know that from here, on the eastern side, the horizontal displacement about 60 to 80 millimeter per year. But in the northern Taiwan, maybe we are very lucky. So the displacement is smaller. As I say that the large scale landslide initiated by CGS, also by Professor Lin from NCKU. This is a very simplified result because in Taiwan the total area is about 36,000 kilometers square. But from this 6 year, we identified this kind of potential site. And when we invert to the whole Taiwan, maybe the figure is like that. We may have roughly about 5,000 to 6,000 sites that with the potential large scale landslide maybe feature, topography feature. Among them, about 750 sites that with the high susceptibility, and the most of the thing we concern is which one or which site that's nearby with a village or with inhabitants there. So we estimate maybe about 150 sites. That's, you know that in Taiwan, whole Taiwan, maybe we have 150 sites and with high susceptibility, and nearby they have a village there. This is the figure, two figures. We always think that this kind of topographic features concerning with large scale landslide. It's very obvious. You can easily recognize that when a landslide occurred, then it will cause this kind of topographic features. This is another one, explain the similar things. Then we have this kind of topographic features. listed here. As Professor Pasuto taught that, with developed unstable slope, which one belong to the early stage or medium stage or the late stage? We listed here only all the topography features, but maybe we must divide it into different stages, because different stages may have different kind of features. As I prepared the presentation, I spent a lot of time to think, what do we have, or what should we do for the large scale landslide? I think we have many different faults concerning with this issue. Like the first one, we must delineate the potential areas. The second one is identification of topography features using LiDAR DEM. Last year, finally we complete nationwide LiDAR DEM data in the whole Taiwan. It spans 6 years to complete that. So we now have a very good, precise, high resolution DEM data, also DSM and also photograph. The third fault may be magnitude of the landslide, because the landslide may be the very big one, maybe very deep, maybe the volume very big. Then the fourth one is geological materials and discontinuity related to the landslide. Because CGS spent many years to investigate this kind of landslide, and then we found that maybe most the features or most the mechanism concerning with geology very closely. Then the fourth topic I want to discuss is hydrogeology in landslide. Because today I have only 20 minutes, so I concentrate these 3 topics. In this year, on April 1st, that day is Foolish Day. But this is from Professor Chigira. He wrote an email to me and to Professor Lin. He said that I am surprised again that the gravitational slope deformation in central Taiwan extends so deeply and so widely. These 3 pictures represent Professor Chigira. He works very hard in the day. As you can see, he wear a very formal uniform when he made the field work. But at night, he also drink very hard. That is a very a person who works always very hard. This slide I added in the presentation because I think this table will be very important for me to explain something. As you see, the title of this table is the probability of large-scale landslide classified based on geology, geomorphology, slide mechanism, and also upslope and downslope condition. As he listed here, the first one is geomorphology, and then the second and the third one is geology. Then this one is mechanism. And the other is upslope and downslope condition. These 3 lines wrote by Professor Chigira, he concluded for this table that is prediction of catastrophic landslide sites can be made when you using LiDAR DMs and the geological structure However, quantitative prediction is probably not feasible. Then I wrote here, only well-experienced, well-trained experts can do this kind of job. Because as I will talk about in the other slide, that many topographic features, many people can do this, but when you need something information from geology, that maybe only the geologists can do that. As I told that, we have a very good quality EM data. As you see from the first one to the last one, then you will know that this is what I mean about the good quality. Like here, that is LiDAR DEM with a grid of 1 meter. Then you can see very clearly about the topographic features. I give this picture for some explanation. When at dawn we see the scenery, you may see like here, you can see before sunrise, you can see like here, the scenery is very beautiful, but it's not so clear. When around sunrise, a little to 8 or 9 o'clock, you will see like here, and we can see the mountain or valley very clearly as you see this picture as you see in the Google. Then here we have a circular, maybe with a scarp around this circle. And the other side, other picture, maybe you can see a terrace here. I give 2 examples here. As you see from the left picture that you may see a lot of circular scarp here. Also, you may see delineation here. But on the right side, you may see some delineation arranged in an natural shape. What does it mean? When we note that this is located on the eastern side of Taiwan, then when we know that in that area, maybe this kind of topographic feature made by fluvial or sea erosion to make this kind of feature, then you may know that this may not be caused by a landslide. Instead, it made by erosion. So when we identify this kind of feature, the most important thing is we must go to the field to prove or to find evidence to make sure what kinds of site or what kind of feature is it. Okay. Now on to use some slides also from Professor Chihira. As you see, first we look from here. This is a landslide area. He drew 2 cross-section lines. And this is a cross-section from here to here, from the top to the bottom. Then it gives me a very deep impression that he made a very detailed analysis from a slope. He analyzes this slope angle changed a little. Then use this kind of data, he explained something. Like here, it means irregular shaped slope surface. As we see from the topography map, it's very often. Then when we use so kind or so good quality data, what can we identify? I want to use this to illustrate something. Maybe from the surface, because we have good quality DM. From the surface, we can have either irregular shaped surface or surface with maybe some regular topographic features. That's only the surface. But inside the slope, what kind of information can we have? When a geologist makes a good detailed survey, maybe he can get something about maybe this kind of discontinuity means that is the cleavage or fading plan. The other, like this vertical discontinuity, it represents joint. So when we have the surface topography features, we must have some other geological data to explain what have this kind of mechanism make this kind of feature. Another things I want to talk about is here. The first time when I see this, I think, oh, it's very clear that everyone can easily know what does it mean. As you see here with parallel delineation here, what does it mean? It maybe means like the explanation from Professor Chihiro. Usually we use this kind of, that is called RRIM, Radial Relief Image Map. That is for expert or other people can easily understand. This is a feature from volcano, so you can see some volcano cone crater like that. But from here, maybe when you use this rainbow color, can let us easily to know that this kind of topography feature, what does it mean? Another example I want to talk maybe is as I wrote here, agree or ignore or deny. Why do I wrote like that? Because this side, this slope is the target I want to talk about. Because here, the slope on the top with the railway, highway number 1 and the expressway. Professor Chihiro used that DN identified this slope with different kind of unstable phenomena, but I don't know which stage it belongs. Then he told the engineer, told the government that on the left-hand side there's a slope with unstable. I find some evidence that it means that maybe unstable, but most of the people don't believe that. But for a geologist, I agree with his idea. I don't know which one we should choose. It's about these pictures. You can see that for us in Taiwan, most large-scale landslide may be occurred in this area because this area distributes our metamorphic rock, that is slate and also argillite. And from a different stage, it may develop like this one. Like here with slate with cleavage here, and when well developed the cleavage like here, and also develop a joint. So when you develop the last stage, maybe here, it has the potential to occur buckling. Also, we can use the LiDAR DM to identify the such as this kind. This means the slope, deep slope. So from this, like this one, we can easily identify this is alteration of sandstone and shale. But in other area, maybe it's not so easy identified, but it's a tool maybe we can use in the future and to make the geological map. That you don't need to always go to the field to make a very hard geological work. And this is another picture, another slide that I want to explain to you. For almost all of us, in the past, we made a geological map. We only concentrate ourselves in the undeformed area. As you see from this here, Professor Chihira divided into bedrock, also gravitational, deformed. This kind the data, when he collected the field, that invited into different classification. And like here, we can measure the cleavage bedding, and when we draw a geological map, maybe like here, what does it mean? Should we do this kind of work? I think when we do a landslide investigation, maybe it's very important. As you see from here, we know that when you maybe have some cleavage or bedding attitude like here, then we maybe can use that kind of data to infer this kind of result. As you see from these two pictures, it's very interesting. This picture took from this side. Then you see only the parallel slate and sandstone alteration. But from this side, you see that is completely another things, because here occurred doubling of the slate rock. How many times do I have? I mean, okay, thank you. Okay. Well, now we use well logging to have more maybe good data, so we can make a very different kinds of result. As here, when we use well logging and have measures something different physical property, then we have this kind of data. This is in Lucerne area. In the past, we have this kind of conceptual model, but when we have more detailed data, my colleague has drawn this kind of data. I don't know whether it's right or wrong, but when we have more data, we can do this. Also, the last one I want to talk about is hydrogeology. Maybe I use the last one. This is drill core from alluvial plain, so you can see gravel, sand, or sand, coarse sand, or medium sand, fine sand. This is mud, clay, or silt. But when we drill a core in the metamorphic rocks, we may have this kind of result. Then we must think, when we talk about hydrogeology, this kind of category may be used, but we are not very familiar with this. As I ask you, what is aquifer? What kind is aquitap or aquicrude? It means different. And when we investigate a slope, then we must maybe different this kind of hydrogeology meaning. Okay, this is the last slide for my presentation.